In this section, we will be talking about acceleration. Acceleration can be defined as changes in speed, changes in direction, or changes in both speed and direction. Acceleration is a vector. To understand this graphic, we must understand that an object is accelerating or increasing its downward fall by 9.8 meters per second. That means that in 1 second, the velocity has increased or changed by 9.8 seconds. In the following second, a total of 2 seconds, it has increased an additional 9.8 seconds to get a total velocity at 2 seconds of 19.6 meters per second. The velocity continues to increase so that eventually by 3 seconds, the total velocity when the rock hits the water is now 29.4 meters per second. This graph is not entirely accurate because it does not take into account forces of friction caused by air resistance. That is to say, in reality, the fastest velocity of something at free fall is usually measured at 90 meters per second. That means that the velocity will not increase indefinitely because of air resistance and friction, but will eventually reach a maximum velocity of 90 meters per second. We can find acceleration using this formula, in which Vf stands for your final velocity minus Vi, your initial velocity, divided by time. Technically, this formula should be change in time, represented by a delta, but for this introductory course to physics, we will simply put time. Okay, let's look at a couple simple graphs. This first graph, we will notice that a skier is increasing at a speed of 4 meters per second. We see this illustrated in the graph because for every 1 second, the speed increases by 4 meters. At 2 seconds, 8. At 3 seconds, 12. At 4 seconds, 16. This is pretty straightforward. What this graph does not illustrate is that eventually the skier will reach a maximum acceleration in which he will no longer continue to accelerate but will remain constant. Now let's look at the following graph. This graph shows a person who is maintaining a constant acceleration. In other words, they are not going faster or slower for the first 10 seconds. Then, at a mark of 10 seconds, they begin to decelerate, which is also a form of acceleration, negative acceleration, showing that at 20 seconds, they have ultimately come to a stop and are no longer moving forward. This final graph shows the acceleration of an object in free fall. It continues to accelerate at a faster and faster rate until eventually, what this graph doesn't show, it reaches a terminal velocity, remember, of 90 meters per second, in which it will no longer accelerate but remain at a constant rate of fall.